This is made up of wires, and we are decompiling Castlevania Symphony of the Night once again. We started looking at the Medusa overlay yesterday, and I think we'll stay there because there's a little bit to be done. I did submit a PR yesterday. We started doing some work around how to determine where splits were in that ROM, or binary, or overlay, whatever you'd like to call it. And I was doing that based on other work that's been done on overlays that we've previously been doing. It looks like the boss overlays look a lot like stage overlays and have a lot of the same shared resources in them. And so we can use stages to find logical segments within those files. And then within those logical segments, we can break those apart to use some of the shared code that we have. And so we might spend some time today looking at one of those segments and determining whether or not we should or can use shared code relatively easily. But I think we'll look at decompiling a function, one of the remaining functions as well. If you're not familiar with the Castlevania Symphony of the Night decompilation project, go to soten.z.dev and you'll find the progress for the overlays that we've been working on. dra.bin is the main game engine, still one function remaining there. Richter was the first overlay that was, I believe, completely decompiled code and data and is completely relocatable. One function left, roaming's often on the stream. I'll have to remember to ask him if he's finished with that. We were working on that function off and on a few weeks ago on this stream, but then roaming took off with it, and I think it's his to take the credit for. We did spend some time on the center stage as well, looking at the HD version of that. So that was imported, and the blip that you see in the progress here is because we imported a second version of the game. So the PlayStation Portable version of Symphony of the Night actually has two games embedded on it, two versions of Symphony of the Night embedded on it. I should say the Dracula X Chronicles for PSP. The version that we know and play, we call the PSP version. The second version is called the HD version, and it looks like more of a direct port of the PlayStation 1 version early on when they were developing it. So instead of references to files on a CD in a CD file system, it has references to files on a hard disk. So that version was imported, slight differences, but now that one looks like it's completely decompiled as well. The Medusa cutscene overlays are not in this progress report yet, and I actually just pushed a branch. Yeah, so Biz Murphy's pointing out that the HD version isn't port, it is the PS1 version. And what's interesting, I think, about it when I was looking into that, it's GCC compiled and everything, not MetroWorks like the other PSP version. All right, let's look at what we were doing yesterday, kind of catch up there, and then continue on. So on soten.z.dev, you'll find a link to the GitHub repo where all this stuff is. I submitted a PR this morning. I finished off some of the work for this RBO 3 split, the Medusa split. And so yesterday during the stream, I went through, there's one large C file for it, and I just kind of annotated where each of those splits was. And then what's involved in splitting that file then really is just finding the offsets for all of those functions and defining them in the splat config. It's pretty straightforward. The trickier part in general, I find, maybe other people feel differently, but the trickier part, in my opinion, is RO data segments, because RO data could be static strings. Biz Murphy pointed out yesterday that he had a statically defined struct that was showing up in RO data. So it can be data, constant data, but it's also jump tables for functions with large switch statements in them. And so the way that GCC and MetroWorks implements switch statements is once they get past a certain size, if you have one or two cases, they're implemented effectively the same as normal conditional statements in control flow. If condition jump here, otherwise continue on and execute code. When you get large switch statements, however, it condenses all of that logic up into very compressed conditional statements. And when those statements evaluate to true, it goes to a table to determine what address or offset to jump to. And we don't see that as programmers when we're programming in C, really. We just think the compiler's doing something. It's going to do the right thing, but it's generating additional RO data in a different segment of the program. And so we need to figure out where all those offsets are, and that's not always straightforward to figure out. And is it worth doing on the stream? I don't know. There's kind of some trial and error and hit or miss. Hey, Project Omega, nice to have you on the stream. But that's all done. And so what you end up with is, instead of one large C file, you get these individual C files that are much more concise, and they can start being merged into what we've done in other stage overlays, where effectively each of these files just becomes an include for shared code elsewhere, and we can get rid of all of this. So we started looking at that, splitting them up just by comment, and I finished that off last night doing the rest. And so we see some of that, the code that was decompiled there yesterday. I am going to work on the same branch because that is that's set up the way that I want this morning. And let's find what the next thing we want to decompile is. I am going to just make sure that I'm up to date, and that looks fine. So now we just have one C file that has code that's specific to the Medusa overlay. So this is RBO3. One thing I noticed, and anybody in chat can comment, when the Medusa overlay was imported, this is my Amerocentrism shining through. The overlay in the README was given the name Medusa. I could only find one like European Latin language that spells Medusa this way. I was actually surprised a little bit that that it is spelled basically the same way in all the Romance languages and other Latin Germanic languages. I did find at least one case where it is spelled Medusa, but definitely not the common spelling. So if anybody knows where that spelling comes from, feel free to chat. Tux Complays asking, what are the duplicate functions, and are they really dupes? Yes, they are really dupes. And we can look at that report. There's a lot of them. And why is there a lot of them? Because code is literally compiled into each of the overlays. So each stage, in this case, boss, is what we're going to be looking at. common functions related to creating entities, finding entities, the red door that you go through, orbs, relics, things like that. That compiled version of those functions is copied into every single stage. And then stages also have additional code specific to their stage, and they also have specific entities or enemies and other things like that compiled into their stage, which is one of the reasons that modding the game prior to what we're doing with this decomp project is hard, is because if you want a warg in the marble gallery, for example, that code doesn't exist there, and it doesn't exist in a shared place in memory for you to be able to do that. You would have to recompile marble gallery with the functions and data related to a warg to get it there. And so the randomizer community and other modding tools haven't had a lot of luck bringing in things that aren't already in a stage into a stage if they haven't been shared there. But yes, there are a lot of functions. These are identical duplicates when the project was earlier on. The functions were copied into each of the overlay trees, source trees. But now, usually, these are moved out into shared header files, and then those shared header files are brought in. Yeah, the overlays, they're kind of like an SO, a shared object, dynamic library DLL for Windows people. But because of the way the PlayStation and PSP work, there's no linking step that would exist for most operating systems and library loaders. And so when overlays are brought in, you specify a location in memory, and you say copy the data from the disk, and it's whatever the size of that overlay is just copied into memory at that particular address. And then everything else is expected to know enough about the game in that specific memory location to access things within that memory location correctly. So for code within a stage or stage overlay, all the references are at a particular offset, which is 80180000. And so every absolute reference within that uses that base address to calculate the offset. And then the main game engine and other things like that use some data that exists at the start of that address to get a list of functions, basically, that it can call into, kind of the API for the stage. All right, so that's duplicates. Yes, there are a lot of them, and for the most part, so there are some little more detail, maybe more than people want. The duplicates tool, what it's doing is going through and trying to find this in overlay. So when we extract code, Splat is able to go through and say, okay, here's the function boundaries, here's a function, here's a function, here's a function. Splat, unless we tell it what the name of that function is at that particular address, it's just going to give it a random name like func 80190 because that's the address it's at. That's Splat's convention for naming functions that it doesn't know what they are. And so the duplicates tool comes through every time code is checked in, maybe once a night. I don't don't trust what I'm saying about how often it runs, but it comes through and effectively looks at all of the functions and says, I have this function, is this similar to anything else? And in this case, create entity when in horizontal range and create entity when in vertical range. those are similar, and so it's going to group them together. And it does that through Levenstein distance. And I talked about this a little bit yesterday. The way that our current dupes tool works is by looking at the opcode for all of the MIPS instructions and basically creating a string of those opcodes and then comparing those strings, which is relatively efficient, but there's issues around the arithmetic operations that all use the same opcode regardless of what they are. And so we get duplicates in this report, like horizontal and vertical range. Those are different, but our tool says that they're 100% the same. So we have, there's some minor issues there, but it does help identify what those are. And one of the major things is going through then and saying, all right, for NOO, I have this this anonymous function that hasn't been given a symbol yet. I know that it's going to be either create entity one in horizontal range or create entity one in vertical range. And now I can go and name that symbol, and other code that relies on that can be imported more easily. So it does really help with importing. And a significant amount of each of the overlays is duplicated code. Okay, so let's see where we were going before. So we're going to go to RBO3. This is the remaining code in this function, or in the Medusa overlay that needs to be decompiled. I'm going to extract, because I don't think I have these, excuse me, I don't think I have these extracted yet. I'm going to find whatever the next smallest one is in this set. So I'm going to look in BOSS RBO3. The directory structure of these assembly files matches relatively closely the directory structure on the PlayStation version of the game in just the CD. So I want non-matchings for the RBO3. And most of these are reasonably substantial. Let's look at this. This one here. It's this guy here that we're going to be looking at. We'll open that up. So we have a jump table. So we'll have some state machine in here. That'll be a little more complex than we've been doing lately, so that's good. So I'm going to copy that, and then we're going to go over to decomp.me. You could do this a lot of different ways. Decomp.me, I think, is a pretty nice tool. So we're going to upload our assembly that's been extracted. And then oh, is there streaming issues? Sorry about that. We have a guy came out last night and he's like, yep, your internet sucks. And we have to send somebody else out. So there was people in the neighborhood working today. Apparently I'm the last Luddite in our neighborhood that's still using cable internet, and everybody has moved to fiber except us. So bad on me. So we're going to upload this to decomp.me. Decomp.me is a collaborative editor. It's going to allow us to write C code and see what the assembly that's generated is. Oh, this actually, these have been going too easily lately. It's going to show us the assembly that we uploaded, which is in this first column here. Can't just select the first column. And then what we're compiling here, and give us kind of a numeric value of how close we are to the match. When we upload the assembly, a decompiler called M2C is going to do a best effort at decompiling this. In this case, it did pretty well. It's already at an 82% match. But there's certain things that we need to fix to get it all the way, and we can't contribute it back until we're matching 100%. So we don't even have any warnings that we have to fix, which is awesome. There are a few things that we will need to go through and clean up before we continue. arg0, that's the default argument M2C will give to the function. We call that self. There are some go-tos. Usually I like to clean those up. And then we have some of these where the symbol that we've given, or that that's been defined for these, when Splat is extracting the assembly, it looks at a symbol table, which is just a name and some address. And it says, every time I see that address, I'm going to give it this name, this symbol that you've told me. And so we've done that for all of these GAPI functions. However, these are actually accessed through a struct, and these are fields in a struct that are function pointers. And sometimes making those changes affects the compilation score quite a bit. In this case, it didn't, and it actually is regressing a bit, but this is the correct way that these should be. Let's see if there's anything else worth looking at. I think that's okay for now. I'm going to kind of go top to bottom. The ones that I've been doing lately have been relatively simple. So the order that I usually go through things, I'm not in practice. So that temp v1, one of the strategies for doing this, and this is going to be very project dependent. For Symphony of the Night, we know that the developers didn't use a lot of local variables, and so when there's assignments to a local variable, that just gets assigned to a field in a struct, which is a global, or even just a global value, or gets assigned to something in an argument or returned, various other things like that. Usually that is can go away, and the compiled code is closer. I don't know if we'll need the PSP version, but another strategy for dealing with this is looking at the PSP version of the game, which for the most part is the same code, but a different compiler, and that compiler gives us slightly better diagnostic information about how the code was structured. So I want to get rid of this particular block, and in all of the cases where this block is being jumped to, it looks like we're always incrementing step, and then, incrementing a variable and then assigning it to step. And so this is just incrementing the step, and we can get rid of all of these cases. We do need to make sure that when this code executes, that a break comes afterwards, because that's what would have happened if we would have jumped to that location. So GCC will look at that, and it will combine all of those into one common area, which is what it does during its optimization pass. And M2C, when it's decompiling, just isn't aware of that and can't figure that out. And actually, that last one basically solved most of the issues. Now we're really close, 95% already. Yeah, time to get fiber. So when this house was built, they actually ran Cat5 for all of the phone lines in the house, and I've been able to repurpose that for a network in the house pretty well and get pretty good speed, even with the old wiring. And what I wanted, if we did run fiber to the house, what I wanted them to be able to do is to install the ONT outside and then just use that existing Cat5 to run to the router inside. But where I live in the Southwest, the temperatures are extreme, and the installer told me that it kills their boxes to have them outside. So then I have to think, if they're going to run fiber into the house, where do I want them to run it to without having to rip up too many walls and things like that? I don't want them to just drill through the exterior wall in the house. So I need to get up into the attic and probably run some cables and maybe add some power outlets places. We'll get there though. All right, so let's see where we are. Let's look at where, what are some of the issues that we're running into. The R in this column means that we have register differences. So somewhere around line 20. I didn't fix these. These are also struct access, which might fix our register issues here. Tile map, is that? And there's some additional I don't know if our garage is cool enough. All the wiring for the house comes right outside the garage, and so I did consider, I wouldn't mind, I guess, if they punched a hole into the garage. That wouldn't be as big of a deal as going into the house. Okay, so sometimes cleaning up some of that other struct access helps. In this case, it didn't. I'm not going to worry about register allocation yet. The way that GCC and MetroWorks allocate registers can be, what's the right word? I won't say tricky, but you can't always control, especially with GCC, what registers are being used. So one thing I see here on line 26, this step, or the reference to step there, and then on line 34, these are all using register S1 instead of S2. And our stack size is different between the two. So that likely means that one of these variables either shouldn't be here, and so we're giving a 16-bit value on the stack, but really there's a temporary variable that's being used somewhere else, and the compiler treats that as 32-bit, maybe for both of these. Or these should be 32-bit values, and that would increase our stack size as well. So let's find where these are being used and if we can get rid of those. So the first thing I'm going to do is check whether this, we'll rename temp v0 entity. I did start a playthrough yesterday. Mottzilla's on the stream occasionally. He wrote a tool for creating save files, and that probably would be nice to get a save file right before the Medusa fight so that I could show some gameplay here. But I haven't looked too closely at his tool yet. These are all wrong as well. These are also only being used when entity is not null. So I'm going to try moving these down and see if that works. Hey, Nate the Great. Not happy, not happy. So I'm going to rename these. I'm a little surprised that these need to be outside the condition. It's possible. Let's invert this and then maybe it'll make more sense. So we're loading this value as a unsigned. However, the original version was loading it as a signed value. We also have one. This reference up here is coming in earlier. Let's look at this. So here we have an entity, and then we're looking at a value that's 1780 away, and this is one bug with M2C where what it wants is an address offset from this particular reference to this value different in memory, but it doesn't take account. It knows, and it generated this. It knows the type of this value, which it should be able to determine the size. Maybe not. Yeah, it should be because it knows offsets into fields and structs. But it just gives us what the basic addition would be, but that's not how pointer arithmetic works. Pointer arithmetic is based on the size of the pointer that you're adding to. And so in our generated assembly here, we get this plus 4200. That's because it's taking the size of the entity and multiplying it by hex 780 or 1780. So I'm going to pull up a calculator and figure out how many entities away this is. This is actually somewhat similar to the one from Monday, where, and I'm going to look at the size of entity. We were looking at the entity before the entity that's being operated on, so we're doing a -1 offset into the passed-in value. So BC is our size. So that's 20 away. So here we want all right, and that gives us not quite the right thing. Did I not do the right? 1780 divided by BC is 20. So I'm missing something. And what size? So is the EBO? EBO divided by 20 is 75. My local definition, or my context definition, is different from what's in my context. Though, I don't think that would matter. Okay, I will assume that it's hex 75 and continue on. Oh, I haven't seen that. So Nate the Great's mentioning Mott wrote Snake for N64, or N64, for Soten. Explain, give me more details. I'm going to look at this and see what this is. Oh, the offset is too low for it to be part of the stage overlay. Oh, it's part of... so something very similar is being done in... Oh, that's... So let's look at this fireword. My hex calculator gave me 20, and so I put in decimal 20 when the value was 32. That is cool. So is he having to? He was generating MIPS code and replacing existing functions in Soten to make this stink game. All right, so this is this may be very similar to what we're doing here. I don't really see, I guess, much other similarity though. So we'll go back, but whatever this entity is that is 20 away, 32 away, is used for the fire warg as well. So we have cases here. I usually like to try to determine if there's a way that we can keep the cases in order. In this case, however, it would require duplicating this code. So I'll leave it like this for now. It does look like, really, though, that this section here, loading these offsets, is kind of the major thing that's wrong. Let's look at the tile map struct. These are signed. So why are we generating? Why are we generating unsigned? Well, that's curious. Let's see where this var v0 is. It's not used anymore. Okay, so what I'm trying to figure out is we're generating a load high unsigned instruction, which means we're trying to load a 16-bit unsigned value, and the original code is loading just a 16-bit signed value. It's unclear to me, though, why that might be. But also why these values aren't used until down here. So we're storing the value of S3, which is the result of that subtraction. Why these are being done so much earlier, regardless of whether or not the entity gets created. So if that creation fails, those values wouldn't be necessary. So why are we even doing that work? Let's see what else there might be. So when I'm looking through the rest of this, I don't think these are going to be 32-bit, but we can try for kicks. That actually helps quite a bit. All right, so getting back down here. So that solved the signed problem, and that's doesn't quite solve our stack size. So we're still 4 bytes off on the stack size. Yeah, exactly. All right, let's look at some of these others and see if there's anything that we can do about those. The rest of it looks okay. I am going to try moving this up. So let's pretend that this is 2 different functions or 2 different cases that do the exact same thing, and that they exist separately from one another. Okay, that doesn't help our... Sometimes things like that may help register allocation. because the code is coming in a different order, and so the optimizer treats it differently. Oh, it was not happy about that one. Do not taunt Happy Fun compiler. Okay, so let's see if we can force more data to go to the stack. What we want to see is why might the compiler decide that it needs 4 additional bytes? And it could be that we are telling the compiler that we have need for a structure that we don't actually have a need for. So I'm going to try to use force these into a rect and see if that makes a difference. Not in the way that I wanted. All right, so what else might be happening here? This is probably time to start looking at the PSP version. This is somewhat interesting. Looking at the, I don't think this will make a difference, but looking at how the stack is being set up. So the stack is, what is that, 24 bytes in the compiled or in the retail version versus ours being 20 bytes. And then we see this S3. So this is register S3. It's being assigned the same offset on the stack, but then S1 and S2 are being assigned different offsets. This one being 4 bytes away versus ours being 8 bytes away. Which is somewhat curious. So then that down here on line 51 and 52, we're using different inverted set of registers from above. So yeah, let's look at the PSP version and see if that tells us anything. Unfortunately, register manipulation is not as straightforward with optimized GCC. So what am I going to do here? I'm going to split config. I think I still have this, right? No? The tool that I had to split this originally is considering it a stage, but that's okay. It's not a stage, and that's okay. So now we need to know what we're trying to do is find this function in the PSP version of the game, which can be a little tricky, but we'll see if we can do it. So we have a lot more splits. What we want, this function was around 4K, so I'm expecting something around 6 or 7K. If we can find something with a time attack controller to find, that would be helpful. And unfortunately, that symbol doesn't appear to be defined yet. What else do we have? Play sound effects. Is that in there? I don't think most of these symbols are going to be defined, unfortunately. All right, so let's just find these. Actually I just deleted the one from Monday. I had all of these. We found the one on Monday. And I got rid of it. Which would have given us approximate location. That's kind of the hardest part, is trying to figure out which. So we want to function with a J table. So we don't have many. We also can look at the splat config to see what functions we do have symbols for, where do they come in the list, and try to figure out which of these segments we should be looking at. I'm guessing it's this 4DO. So our code comes before st update after breakable. Red door is going to be the first shared function that we'd have symbol for. So it has to be less, the offset has to be less than red door. So red door is FDO, so we can look at these other FDOs. Or 4DO. All right, so here we need some clues to help us determine if this is going to be the right function or not. So we want, we can look at the jump table. We want a jump table with 7 cases in it. Let's see if there's any preamble that's worth looking at. So the switch at the start is going to be looking at, let's see, line 14. We're going to be looking at offset 2C. And we are, but that's going to be the case for most of these, is using the step as a switch. In this case, though, this is kind of the main thing here. In the GCC version, we're saying if the code is less than 7, basically skip the switch because we don't need it. In our PSP version, we're saying less than 6. It could be equivalent. Let's see if there's any other magic numbers that would. So there's a bunch of OX81, OX80. Let's look for those. I don't see either of those, so I'm gonna try this other one. Doesn't mean that wasn't it. Yeah, this one doesn't have it either. But this one is it has the same number of cases. So let's try this one. I'm not going to worry about the jump table because we're just going to see if our code is the same. So we're going to create a new scratch, PlayStation Portable. And this will give us some errors, but that's okay. Oh, not that error. That error is not okay. Because we're just going to take our code and paste it in here. Basically, the jump table wasn't available. So this is quite a bit different. Okay, so let's try the other one. That reminds me, Nate. I watched your video and really want to set up that exploit. Do you have a reference to the save corruption? How to get the save corruption that was necessary to set up the inventory hack? Unfortunately, the oh, this isn't it either. Okay, so let's see what else. How else can we find this function? Could the PSP version not have a jump table? I'm going to look for for OX81. So what we want with the 81 is an add, I think. No, subtract. Yes, let's try this. These are in between the. This is part of eCollect and some other shared code. This may be more promising. Or not. Okay, so here we are back at this 328. Let me look for this 301. That's that may be unique enough. Yes. All right, this looks better. So when I watched your arbitrary code execution video, I went through looking for sock folders posts. The posts are relatively old, and unfortunately, they everything I found referenced Twitch videos, and those Twitch videos are long since gone. That's interesting too. That hack works on the PS3. I guess why wouldn't it? Because the PS3, when doing running PS1 games, has to allow all the basically executable memory everywhere. Oops. No. Yeah. So I think I found the right function now. Yes, this is the right one. Okay, so now we have the PSP version. So some trial and error. The way that Biz Murphy probably has... I feel like he can find functions in other versions of the game very quickly. And I tend to not. So it does look like these were copied, possibly. Yes. So usually what I do is I look for unique values. So in this case, I found this hex 301. That's not something that's common and going to be used elsewhere. So the number of functions that have that value should be relatively small. Sometimes, though, there aren't things like that. All right, so this value looks like it's being pulled out into a separate variable. So what I'm doing is basically using the PSP version, which was compiled with MetroWorks instead of GCC and is not optimized, to try to try to find anything that the GCC version may have glossed over or may make difficult to find. So that, yeah, this other variable is not necessary. So here we're pulling entities. The way that entities is being loaded here is slightly different than what is happening here. Let's try pulling out the player, see if that works. Okay, that seems better. Oh. This construct that M2C created is really, it's not looking for whether or not this is less than 255. It's looking for whether it's less than 81. And the way that GCC generated that code makes that less obvious. Sign less than immediate. So now the the PSP version is also checking if it's less than OX180. So this seems to be different than what's happening in the PlayStation version. We can go back and fix the PlayStation version though to match that. So here we're checking against greater than or equal to OX80. But that doesn't fix the registers. We don't care about immediate values because those are going to be different between the PlayStation and PSP version of the game. 29. So we have stack differences. Not worried about that right now. Immediate stack. So let's see if we can get rid of this player. No. Weird. Weird. I may be able to reuse entity there though. And that possibly helps with stack alignment. We have an extra 16 bytes on the stack. So down on line 62, we have some issues. So this ordering may be what the root cause of this issue here was. Oh, what did I break here? So the PlayStation version is not having this. Let's see if we can coax it. Oh, is this Don't worry about missing the stream. Entropy. Glad to have you back. I'm just trying to figure out what the cause of this. This difference here is usually when the PSP is happy with something, the GCC version falls in line, but in this case it's not. What else is known about hex 80? So that's 128 decimal. I'm missing something. Let's go back to the PSP version and see if there's anything else obviously different. Line 61. It looks like here this instead of this value being a constant, and I noticed that in one of the other Medusa functions as well. There are several constants in the PlayStation version that get pulled out into globals in the PSP version, and it looks like that's what happened here. It's possible that this is a const global, and maybe GCC picked that up and just inlined it. Yeah, but the other major thing here just seems to be the stack. Let me pull that out and see if that does anything. So back here on line 63, we're loading this value here. It's being loaded as a 32-bit value. It's possible that it's a pointer, but we'll try it just as a... Yeah, so if this is const, it... Yeah, that's not quite right either, though. Oh, this might be an array. Let's try that. I don't know if that's going to make a difference, but we'll see. No. Windows 2000 was, and is, I think, my favorite version of Windows. The style of it, the stability, it just hit like on all cylinders for me. NT4 never, I mean, it was fine, but 2000 is just, I don't know, peak Microsoft in my opinion. And then XP, I always have to go back to the watercolor theme. XP watercolor theme is pretty reasonable. But 2000 will always be my favorite. Post XP, I left the Windows world and never really came back. So our PSP is actually pretty close. There's still a few issues related to registers and stack size, but I'm spinning on this a little longer than I wanted to. I'll probably come back to this offline and see if I can figure it out. I did want to go over one other thing that that was brought up. So we have a bunch of tooling that's really awesome, and I think that's one of the things that is cool about the Symphony of the Night decompilation project is that a bunch of the tooling that exists really helps make doing all this work easier. And one of those is the linting tooling. And Biz Murphy pointed out this morning in Discord that we have, I wrote a linter for, now I have to remember what it's called, for finding different enum values and putting them in place. And there was a case that wasn't being hit. And so I want to go through and fix that. So yeah, draw modes and draw flags. So let me save this and go back to the function that we were working on yesterday. So in a lot of this code, when it's decompiled, the decompiler will put constant values or immediate values, like 0 here for draw mode, and we have enums for each of those. Here's another one where flags, we have this huge hex value for setting a particular bit in this flags, and we have nice enum names for each of those things. And so we don't want these just numeric values in there when there's something much more readable for humans. And so we can define what those enums are and what their what bit is related to that, and then this tool will come through when you run make format, and it'll update all those places. But one of the things that it doesn't catch right now is conditions. So when you're saying if you're comparing a particular field versus a value. So we're going to add that. So what we want to do is say if you're doing something like that, we want to replace this value here with whatever the appropriate enum value is. And this this friendly regular expression is what is used to match. And I think we just need additional equals here, and I think this will work as intended. We do need to check for the places that this is used are not just ends of line, but also in parenthetical groups, so we'll add that there as well. So the regular expression explainer. So we're looking for pointer or field access. Then we want any number of spaces. So this parentheses here is Rust's way of interpolating this with the field name. So whatever the field name is for this particular instance, any number of spaces And then either an ampersand equals or equals, equals, or none of those and just an equals, any number of spaces. And then some numeric value optionally with a tilde to do the bitwise inverse. And let's see if I have any, I don't have tests on this one, but let's open that other one. And so we have some tests on here. Let's add a test. So we want to say if draw flags equals 8. And we'll put this in a condition to make sure that this all works. Yeah, sometime around the Windows 2000 time frame, I was doing Linux administration and a good amount of my schoolwork I could do in Linux as well. And then, so dating myself, sometime around then was when all of the Microsoft antitrust was going on, and I kind of challenged myself, can I live without Windows? And I had a laptop that was stolen, and so needed a new laptop and decided to get a PowerBook. Also dating myself. If any of you know what a PowerBook is. A better name than a MacBook. And okay, so partially working. Oops. I didn't like that. Okay, so we need to capture what the terminal value is for each of those and use that instead of hard coding the parentheses, or sorry, semicolon. But then that should work. So before I switched to using a Mac primarily, I ran Gentoo. I was very happy with Gentoo. Alright, so now this wasn't being captured before, but I do need to capture it. And that will be the 4th capture. I've never, and this is probably the worst Rust ever. Prior to this, never programmed in Rust. I'm not sure how I feel about it as a language. Yeah, so my my go-to free Unix is FreeBSD, and FreeBSD was actually easy to switch to after using Gentoo, and later I learned that the Gentoo was created by people who left FreeBSD and wanted to work on a Linux, and carried over a lot of the same concepts, specifically related to package management. Let's see if that is going to work. Yep, that worked. I missed the C64. That was a world that passed me by. I had a friend who had one, and we had an Apple II, and what the Commodore 64 could do for games was amazing compared to the Apple II, but then I had a Sega Genesis, and the Sega Genesis blew the Commodore 64, in my opinion, blew the Commodore 64 out of the water. Maybe that was just the games that I played on his, but all right, so we now should have support for finding those enums when doing equality. And let's see what we found. All right, so yep, we got a whole bunch of them. So I'll submit this later, and I think this will be a nice change. Didn't really only find one. A lot of code. I guess not one. It found a couple. But we can support that. That's good. Tooling and automation, I think, is one of the things that sets great projects apart from good projects. And so I'm glad that there's a lot of good tooling and automation here. Yeah, all the different mini computers, that was a world that I didn't really know existed, and minimal interactions with the early like IBM PCs, except for a typing class in school. So I think that's probably where we'll end today. We have some nice tooling additions. Let me give my standard trailer here. So we've been working on decompiling Castlevania Symphony of the Night. Got most of the way on this function in Medusa. A few things to work out still. And then we'll have another one done, and there'll be 6 or so remaining functions that are unique to the Medusa boss remaining. If you want to know more about the project, you can go to soten.z.dev, join the Discord, look at our GitHub, and see where things are. I'm here Monday through Thursday doing some live programming and kind of working through some of these problems with a great group of people in chat. And feel free to join if you want to know more about the project or like what I'm doing here. Please follow on Twitch or subscribe on YouTube. Comment, request, do all the things. I really enjoy chatting with everybody and having you listen to my... If you know what that sound is, You're cool in my book. If you don't know what that sound is, you missed a great period of history. Yeah, so Sutton.z.dev to learn more about Castlevania Symphony of the Night and what we're doing decompiling. And I'll be back tomorrow, and hopefully I'll have a save point before Medusa, and we can do some gameplay and break at some of these things. All right. Catch you all tomorrow.